Hi everybody! Today we are going to learn impulse and impulsive force in 15 minutes. So before we start, can you guys imagine when in a car accident, the force acting on the car caused severe damage on the car and the passenger? Have you ever wondered what type of force involved in this situation? So by the end of this video, you should be able to communicate to explain impulse and impulsive force and solve the problem involving impulse and impulsive force. In this video, I'm going to explain the Newton's third law of motion, the effect of time, impact on the magnitude of impulsive force, and the last one is the application involving impulsive force. Impulse. So let's see what does it mean by impulse. Impulse is given by Ft is equal to mass times final velocity minus mass times initial velocity. And for mv minus mu, it's also known as change in momentum. The equation also can be written as J equals to mv minus mu. And now, we can define impulse as the change in momentum, and the SI unit for impulse is kilogram meter per second or Newton second. Impulsive force. Impulsive force is given by F is equal to mv minus mu divided by T, where mv minus mu is the change in momentum and T is the time of impact. So what does it mean by time of impact? Time of impact is the moment when two objects touch until the objects become at rest. Here, we can define impulsive force as the rate of change in momentum in a collision that happened in a short period of time. The SI unit for impulsive force is kilogram meter per second square or Newton. Now, look at the figures. In figure A, if we drop an egg on hard surface, for example on a plate, it will crack. But for figure B, if we put something nice and squishy under the egg, it ends up just fine. This makes sense intuitively. But how does it work? This caused by impulse momentum theorem. Why does an egg break and not break? As an egg drops on a plate, it does break. But when an egg drops on a pillow, it does not. So why this thing can happen? In both cases, the mass and the change in velocity are the same. But if change in time impact goes up or increase, what will happen to the force? Right, the force will decrease, or we can say the force goes down. Here, we can say that when an egg drops on a pillow, the egg starts to slow down as soon as it touches it. Thus, we can conclude that a pillow increases the time of the egg takes to stop. In easier way, we can say that when the change in momentum is constant, the force will inversely proportional to time. We can conclude that when the time of impact increases, the magnitude of the impulsive force is decreased. And as the time of impact decreases, the magnitude of the impulsive force is increased. So, what type of Newton's law related to this subtopic? This subtopic is related to Newton's third law of motion. But what does it tell us? It states that for every action, there is an equal magnitude but opposite direction. You also need to bear in mind that the forces always come in pairs, which are the action force, and the second one is reaction force. Here is one example of action and reaction force. When a person steps off from a boat, the person will move to the left, while the boat will move back to the right. Here, we can say that there are equal and opposite forces acting on the person and the boat. But in different situations, if the boat is much more bigger than the person, then the boat will not recoil as much as the person moves. Let's see the example of situation related to impulse and impulsive force. The first one is increasing the magnitude of the impulse by follow-through action. But first, let us watch the video that I have prepared. So, what do you guys think after watching this video? Here the explanation. As you can see in the previous video, after the guy kicking the ball, his leg remains swinging, and this action known as follow-through action. A follow-through action after a strong kick produces a large impulse. As a result, the ball experiences a change in momentum and moves with high velocity. The exact situation also goes when a golf player swings the golf rod. The second situation is reducing the impulsive force by extending the impact time. Here, I also attach a video related to this kind of situation. Let's see if you guys can relate the situation with what have we learned today. What was actually happened? So here the explanation. So when a collision occurs, it causes a car to stop and experience change in momentum. Each car has been designed with crumple zone. For instance, is the bumper. In this video, the airbag has been used as the protection for the passenger when accident happens. The airbag of the car will extend the impact time during the collision. Or in other way, we can state that the longer time for the force to act on the passenger, the less damage caused to the passenger. As a result, the magnitude of impulsive force on the car has been reduced. The third one is increasing the impulsive force by reducing the impact time. This current slide shows a pestle and a mortar. The reaction force occurs on the pestle, while the action force occurs on the mortar. As we all know, both of it is used to crush an object. Here the explanation. For this situation, a higher impulsive force is needed in order to crush the object inside the mortar. A pestle moving at high velocity is stopped by a hard mortar in a short interval of time. So, when the object collides with hard surface material, the impact time becomes shorter and resulting large impulsive force. Beside from the previous examples, can you list out other examples that related
to impulse and impulsive force? If you do, good job! Here, I give you another 3 examples that involving impulse and impulsive force in our daily life. The first one is high jumper lands on a mattress. The mattress can lengthen the time of impact and this resulting smaller impulsive force. And the second one is parachutist bends his knees when he lands. This action resulting in increasing the time of impact and reduce the force when landing on the ground. The last one is the hammerhead. The hammerhead's made of hard material. So, this resulting the impact time becomes shorter and high impulsive force is produced.
The next part of our lesson today is solving the problem involving impulse and impulsive force. Let's see the first example. The following diagram shows a tennis ball of mass 0.06 kg hitting a concrete wall with a speed of 50 meters per second and rebounding at a speed of 40 meters per second. Take the right as a positive direction. So what is the impulse on the ball? The first step that we need to do is list out all the information given from the question by using symbols. For mass, we can write as m, which is 0.06 kg. For initial velocity, we can write as u, which is 50 meters per second. And final velocity v is 40 meters per second. The second step is identify and write down the formula that we are going to use. In this case, we use impulse J is equals to mv minus mu. And for the final part is we need to substitute the numerical value and calculate to find the answer. The final answer for this question is negative 0.6 Newton second and it is acting in opposite direction. Let's move on the second example. It states that a helicopter dropped a box of mass 55 kg. Before it hit the ground, the velocity of the box was 12 meters per second. The box stopped after 2 seconds it hit the ground. So what is the magnitude of the impulsive force acting on the box? For this question, we also need to apply the same step from the previous example. The first one, we need to list out all the information given. We can write mass m is equal to 55 kg. The initial velocity u is 12 meters per second. Final velocity v is 0 meters per second. And then, we need to identify and write down the formula. In this question, we write F is equals to mv minus mu divided by t. And for the last part is we need to substitute the value and calculate the value. The final answer is 330 Newton. By the end of the previous slide, I hope you guys be able to understand the real concept of impulse and impulsive force. To improve your understanding, I have prepared some simple questions for you guys to try. The first one, what is the definition of impulse? The second one, what is the definition of impulsive force? And the third one, a car of mass 600 kg is moving with velocity of 30 meters per second. A net force of 200 Newton is applied on the car for 15 seconds. Find the impulse exerted on the car and hence determine the final velocity of the car. I hope you guys be able to answer the question that I have provided in the previous slide. And thank you so much for watching my video. See you next time.